Salam and welcome everybody. Today's lesson is about carbonyl compounds. So, the carbonyl compounds that we're going to learn are in terms of aldehydes and ketones. So, what is aldehyde and what is ketone? So, let's start with aldehyde. The aldehyde is a compound, which is organic compound, by the way. Once you have a carbon double bond with oxygen, and then it's bonded to hydrogen. So in this case, we can consider, or let's say call this functional group as aldehyde. So the aldehyde is organic compound that contains C double bond OH. So in this case, once you find a carbon that has a double bond with oxygen and it's bonded to hydrogen, then we can say this is aldehyde. Okay, and if you want to write this in terms of a structural formula, you can say this is RCHO. So the CHO indicates that you have a C double bond O and H. So let's take an example of real, let's say aldehyde. So suppose that the R group here is alkyl group, by the way. Suppose that you have CH3, and the CH3 is bonded to C double bond O, and here we have H. Then we can say that we have aldehyde because we have C double bond OH. Okay, and we can write that in terms of a structural formula, like you write CH3, and we write the C double bond H as CHO. And we write it in this form rather than writing like COH because we want to distinguish between this and this from alcohols. And that's why we write it like CHO. All right. So this is the family, or let's say the homologous series of aldehydes. And now let's go to the ketones. So the ketones indicates that you have a double bond O, which is same as aldehyde, but the only difference is the carbonyl group is bonded to two alkyl groups. And here, as we can see, this is R and this is R. It refers to alkyl groups. So I can describe that in terms of real example like CH3, C double bond O, and CH3. So in this case, we can consider this is alkyl group, this is alkyl group, and this is carbonyl, then this is ketone. So let's start with more details about what is meaning of carbonyl compounds. What are the conditions that I have in my compound to say this is carbonyl compounds? So the carbonyl compounds indicates that you have C double bond O, okay, and this carbon is bonded to either alkyl groups or hydrogen, and here it must be bonded to alkyl group or hydrogens. So the only, or let's say the possible compounds that we could have are aldehydes and ketones, and that's why we can call them carbonyl compounds. So my question is, do we consider esters and carboxylic acids carbonyl compounds? The esters are compounds with C double bond O and they're bonded to O in here. So according to the conditions that we have in carbonyl compounds, they must have a C double bond O, and actually we have in esters. But we just noticed that the carbon here is bonded to oxygen. Then this is not carbonyl compound. The carbon must be bonded to either hydrogen or R group. So it's bonded to oxygen, then it's not carbonyl group or compound. What about carboxylic acid? The carboxylic acids are considered to have C double bond O and OH. So we have the same story. We have C double bond O, we have carbonyl group, but the carbon is bonded to oxygen, and this is not the conditions to have a carbonyl compound. Then carboxylic acids are not carbonyl compounds, esters are not. Let's start with aldehydes. Suppose that we have this compound CH3, CH2, C double bond H. Then according to what we see, we have R groups that are bonded to C double bond H. Then, absolutely, this is aldehyde. By the way, the group of aldehyde, or let's say the functional group of aldehyde, is always on the end of the molecule. You never find this group in the middle. Okay, so the first step in our compound is finding the longest chain that includes the functional group. So we can start counting it from here. 1, 2, 3. Then we're supposed to have the propane. Propane, okay? Propane is ended up with E. So in the naming of aldehydes, we get rid of this E. We drop this E. And then we add Al. Then if you combine these two words together, you will have a propanal. So the compound's name is a propanal. So let's take another example. Suppose that we have this compound like this, and here we have O, and we have, yeah. So what do we call this compound? First of all, you have to find the longest chain. So we can start counting from here. 1, 2, 3. You can count from like 1, 2, 3. It's okay. But you have to start counting from the aldehyde functional group. All right. So according to what we have, the longest chain is made of 3 carbons, which means a propane. We drop the E. And then we have to add Al. Okay. And we just don't forget that on the second carbon, we have methyl group. And then it will be like 2-methyl. All right. So if you combine all of this stuff together, you will have 2-methyl, no space, propanal. So this is my compound in here. Let's take another one. Suppose that you have this. All right. So the first step is finding the longest chain. We can start counting from here. 1, 2, 3, 4, 5. Okay. Or we could start counting from here. 1, 2, 3, 4, 5. So the longest chain that we have in this compound is pentane. We get rid of the E, pentane, and then we add Al. I just want to write it in different color, like Al. And we just noticed that in the third carbon, we have a branch. So we have a branch in the third carbon, and it appears as 2-ethyl. Okay. Then you combine these together to have 3-ethyl pentanal. So this is how to name this compound. Okay. Now we're done with aldehydes, and now it's time to go for the family of ketones. Let's go with the family of ketones. Okay. We just want to recall the ketones. It's a family that contains alkyl groups, and they have carbonyl in the middle or in between. So let's start. Suppose that we have this compound, and here we have O. The first step in here, we have to find the longest chain that we have in our compound. So we can start counting from the area which is the closest to the carbonyl group. We have to start counting from the area which is the closest to the carbonyl group. So let's start. If we start counting it from here, say 1, 2, 3, 4, 5. Okay. And if we start counting it from here, 1, 2, 3, 4, 5. Just notice that the carbonyl is in the third carbon. So if we start counting from left or right, all of these are the same. The longest chain that we have is pentane. We drop the E. And we have to indicate the position of the carbonyl group, which is in the third carbon. So we write pentane, we drop the E, and then we just write 2 hyphens. We detect the presence of the double bond O, and we put 3, and then we add 1. Then it's read as pentan 3-on, okay? Pentanon. So this is how to name such a compound. Okay, let's take another example. This and this. So if we start with this first one, we just notice that we have 1, 2, 3, 4. Then it means that you have a butane. We drop the E. And you just notice that the probability of adding the functional group, it could be here or here. And if we put it in here or in here, it will be the same thing. It will be in the second carbon. We start counting the number of carbons from the closest one. We can say 1, 2. If the double bond is in here, then we start counting from here. So it's only on the second carbon if we have a butane, okay, or let's say butanon. Then there's no need to put the number. You can't put the carbonyl in here because it will change to aldehyde. So we have only butane on. Okay, this is a butanon. Okay, so in this case, there is no need to add any number for butanon. And the same story repeats itself with propanon. Okay, if you start counting from 1, 2, 3, then you have 3 carbons, and this is the only possible way to make a ketone. If you put the double bond in here, then it will change to aldehyde. So in this case, this is only propanon. There is no need to put the number in between. Okay, so butanon and propanon, there are no numbers like in this in here. So let's take another one. Suppose that we have, or let's say I ask you to draw the pentan 2-on. How can I draw this? Pentanon, first of all, this refers to ketone. And this refers to the position of the double bond O. And this means 5 carbons. So we can draw that in terms of, let's say, skeletal formula. We have 1, 2, 3, 4, 5. The double bond is in the second carbon. We have to say like here. Or you can start from here, it's okay. And that's it. So in this case, we just noticed that we can put the double bond on the second carbon or in the third carbon. And that's why we have to put some numbers. Okay, but if you go for butanon, you have only one choice to be on the second carbon. And here for propanon, it's only in the second carbon. And that's it.